Day geometry. We are on day 2 of CO63. Girls?
Want to restart it?
No, I kind of want to give you just your homework and go sit at my desk and let you figure it out. Because if you don't want to. Multiplying and dividing radical expressions. We introed this yesterday, just kind of comparing multiplying radical expressions to fractions, and then variable expressions. We did the first few together, and basically the pattern that we saw was that the coefficients are multiplied together, just like the numerators of fractions, or the coefficients of variable expressions. 2 times 8 would give us 16. And then the roots are multiplied together as well. They don't have to be the same, which is the beauty of it. With adding and subtracting, you gotta simplify, you gotta figure out, can these actually be combined? But with multiplication and division, they don't have to be the same. Again, just like fractions, just like variable expressions. Root 10 times root 2 is root 20. So you get this solution of 16 root 20, then you have to look at it and decide, am I done? And were we done with this one yesterday? No, because you could simplify. Root 20 turns into root 4 times root 5, which ultimately gives you 32 root 5 as a final answer. Okay? How far did we get yesterday with all this stuff?
Finished
Finish the second one? Okay. Did we do anything in the bottom row? No? Okay. So, carrying on with we're left out. Do the third one. We did the second one. Do the third one.
I already did it.
Great. Then just sit tight.
Why do I not have the first? I don't have the third.
Then do it. Do the third one. James, quiet.
Is it like signals right here? Or is it
I don't want you to be quiet. I want you not to ask.
You can simplify 18.
Luca,
I think. How do you know if you simplify?
if the root has a perfect square factor. So for the third one, have a turn around please. For the third one, we have 11 and 2, which gives us 22 for our coefficient. Our root 6 times root 3 is root 18. Does that have a factor that is a perfect square? It does. 9. Right? So you can rewrite this to be 22 times root 9 times root 2. Or 22 times 3 times root 2. Or ultimately 66 root 2 as a final answer. Okay? For the next one, for that, yes. I'd like you to stay right now. For the next one, for that fraction there, 2 root 3 over root 6 times 3 root 5 over 9. You know, whenever you've got fractions, there's the opportunity to simplify vertically. We do have that here. We could explore it. I'm not going to now, just so that we can get the process of multiplying fractions across. But remember, to multiply fractions, you do go straight across. So you are multiplying 2 root 3 by 3 root 5, which gives you 6 root 15. And then in the denominator, you are multiplying straight across. Root 6 times 9. Even though the root 6 comes first there, you're still going to put the coefficient first when you write the solution, right? And just the order of it, the coefficient comes first, then the root. So we have 9 root 6. We can't combine them to get like root 54 because one's a root, the other one isn't. But we can still multiply them together as the term 9 root 6. Now we get to look at how can we simplify. In? Okay. So we have our coefficients 6 and 9 here. It is a fraction, so 6/9 simplifies to be 2/3. So now we have 2 root 15 over 3 root 6. What else could we do? What else do you see? Discuss. You can simplify the radicals. They're both under a root, so we treat it like the fraction 15/6. What does the fraction 15/6 simplify to be? 5 halves. So now we have 2 root 5 over 3 root 2. Right? So once we did the multiplication, we first simplified the coefficients. 6/9 became 2/3. Then we simplified the radicals. 15/6 became 5 halves. We could have reversed that order, we got the same thing, doesn't really make a difference. But there's one more step we have to do here now. Well, it ends up being two more steps, but now we have to rationalize. We have that square root in the denominator of the fraction, so we have to rationalize this, which means we have to multiply by root 2 over itself, which in our numerator is going to give us what?
2, whoa, wait.
2 root 10, right?
2 root 10.
The root 5 and the root 2 can be multiplied together because they're both under the root. The coefficient 2 stays put. In our denominator, what do we get?
6.
We end up getting 6, right? Because this root 2 and root 2 together make root 4, which equals 2. And we have that coefficient 3, and the 3 times the 2 gives us 6. What do you mean, and then? We have to be done by now, right?
No.
Wait,
Where I'm
wait,
getting the 6 here
No.
is because when we rationalize,
I'm not done.
root 2 times root 2 is root 4, right? Which equals 2. We also have this coefficient 3 as part of our denominators to start with. So we have to multiply the 2 we get from rationalizing the roots by our coefficient 3 that was there to begin with, and 2 times 3 gives us 6. Do you see where we get the root 4 from? No?
Yeah.
Evelyn, the root 4 comes from rationalizing. Because we have this root 2 in the denominator here, we have to multiply by root 2 over itself. Right? Follow me? So root 2 times root 2 equals root 4, which the root of 4 being a perfect square, that's why we do it, to get that perfect square. Root 4 equals 2. Right? So really, in this denominator, we have our coefficient 3. We have our coefficient 3 times the 2
Yeah, that makes more sense.
that we get from rationalizing. And then, of course, 3 times 2 gives us the 6. Okay?
No.
No, we're not done.
Audrey,
Oh, where did the 2 come from?
this one? Because we have to rationalize. We have that square root in the denominator of a fraction, which remember is a no-no, because the root of a non-perfect square is an irrational number, so we have to rationalize it. And so how we do that is we look at the root that's in the denominator, and we multiply by that root over itself. This is back to CO61 part 2. Okay? Hugo says we're not done. Hugo, what else can we do?
The 2 and the 6 can be simplified.
We can then simplify our coefficients yet again. 2/6 as a fraction simplifies to be 1/3. And so our final answer, when all is said and done, is 1 root 10 over 3, which you can also eliminate the 1 and just put root 10 over 3, but I feel like if I do that, I'm going to have people freaking out over where the 3 came from. So hopefully you can see that 2/6 simplifies to 1/3 a little bit easier there if I keep it there.
Wait, where'd the 3 come
Oh, my data.
2/6 simplifies to be 1/3. Okay?
Wait,
And there's our final
Where
answer.
did the square come from?
the square root.
Squaring the answer.
Like, who just thinks of this?
Okay, questions on that one? This is a lot, and that's why those of you that kind of pay attention for a short time and then don't pay attention, you come back, you have a side conversation, then you come back and you doodle, and you come back, it's gonna get lost. There's a lot going on here. A lot going on here. Mario?
For the next one,
Yeah?
2x times 6, would that be 12x?
What's that?
How much is left in the class?
9 minutes.
Bruh. Wait, really?
So 12 root 2x times 3 root 6. Mario's recognizing we are multiplying the coefficients here. 12 times 3 is 36.
And then would it be 12?
And then root 2x times root 6 is root 12x.
So, but they're simplified.
Oh, there's no need.
Can we simplify?
Yeah.
How?
3 times 4.
Yes. We can break this up, and I'll do it every step of the way here. First, we start by breaking up our number from our variable, root 12, from root x. James is claiming we can break that root 12 into a root 4 times a root 3
So you get an extra step.
times a root x. We do that because now we have that root 4, which becomes a 2, and then a 3, a root 3, and then a root x. Which, when all is said and done, 36 times 2 is 72. And then the 3 and the x go together under the root. Nothing more can be done with that.
How do you
Huh?
How do you know?
That you can't do anything more? Because there's no perfect square factor of 3. And there's no perfect square factor of x. You don't know what x is. You're always looking for those perfect square factors.
Alright. So then with
The next one.
I think we can do the rest of them. Just add a
Luca?
What am I ever gonna use?
Never.
This is algebra 2. You will use it in working with various expressions in algebra 2.
But what about in the real world? What about
Mr.
Schultz? So this is basically the matrix.
If you ask me whether or not I should be teaching this, I would say I would be much worth all of our times, and I think I've had this conversation before, if we replace this with the personal finance class. However, I have to teach what the state tells me to teach.
Is that
Hey.
why you're on probation?
Can I start the second one?
Sure, start us off.
So you meant to add a 1 in front of the root 7x3.
Yeah, so the coefficient here is a 1, okay? And so when you multiply the coefficient by the coefficient, you do get that 3 out in front. And then the root 7x cubed times the root of 2x squared. 14, x to the fifth. Good. Those exponents are added. Okay? Multiplied by the same base, exponents are added.
In the 14s.
Can the 14 be simplified? Our only options are root 7 and root 2. Neither of those are perfect squares. So we keep it as root 14.
The x to the fifth.
And then the x to the fifth, the root x to the fifth, if you need to look at your chart, it's back on CO61 part 1. What is the root x to the fifth simplified be? X squared root x. So we have 3 times root 14 times x squared times root x. Now everything that's outside of the root stays outside of the root together. 3x squared. What's inside the root, the 14 and the x, goes together as well. Luca, back to your question about why you might need to care about this. So the only PO of this unit are the first objective and the last one. PO61, the simplifying one, because we will use that in geometry when we talk about 45, 45, and 30, 60, 90 triangles. And then solving an equation involving a radical. We care about that as well, because all of your computerized graphics of your favorite healthy brain-stimulating video games. The code involves roots and things like that, and so they're POs. If you leave this class not knowing CO63,
I'll be fine, right?
chances are in life you'll turn out fine.
Can you just make this
So.
not as a grade?
That I'm not going to do though. That I'm not going to do. Yeah.
Wait, so why are we learning algebra 2 right now if we haven't even gotten onto geometry?
Because if we are going to dive into radicals and roots anyway, doing all of this reinforces PO61, which is the one I want you to know. So the more practice you get with this and the simplifying and what can I simplify, how do I simplify it, reinforces what I actually want you to come out knowing, which is the PO61.
Wait, I'm cooking on this next question right now.
Just give us a
Okay. I'd like you to try the next 2 for tomorrow. We've got a couple of minutes left today.
Wait. Who let James go? Who let James
writing stuff down.
Be looking for all the simplifying options.
Wait, I need more space, but whatever.
Work has got to be shown, of course.
I'm done.
I like the last one. It's for letting me
Oh, crap.
Oh,
Wait, let them all
We're gonna do this all.
That's how you math.